Hi, my name is Cameron Four, and I'm an end-user computing technical strategist at VMware. And in today's video, I'm going to be walking you through the latest Horizon World Operations Overview dashboard, how to use it, how to consume it, how to make it useful, and really understand how to get good operational insight into how Horizon is working, where's your greatest risk from an availability perspective, are there any problems in your Horizon service that could be impacting your users, and really kind of go top to bottom in terms of how to do troubleshooting directly from the dashboard and what everything means. So to get started, you should be seeing the Horizon World Operations Overview dashboard. Basically, the way this dashboard is organized is it's really kind of prioritized from top to bottom into how do users come into the Horizon service and what are the most critical items that need to be monitored in terms of overall availability, connectivity. Can your users click their desktop icon and be sure that they're going to get a desktop? So at the very top, we have the Horizon World Critical Issues Scoreboard. So scoreboards are typically used to identify high-level problems, as well as giving you an overall score for how Horizon, or at least your Horizon service, is performing for your users. And really how it does that is you'll see first two numbers. The first one is the Datacenter KPI, as well as the Network KPI. And the best way to think about these numbers is this is basically an overall performance score for every user and every virtual desktop that they're logged into. So as users log into Horizon, we give them a data center performance score, which is really, how well is their desktop performing. These metrics include things like CPU utilization, CPU performance, memory utilization, memory performance, disk performance. All of these numbers really go into calculating that overall data center KPI score. This is also true for RDS host sessions. So if a user logs into an RDS host and that RDS host has performance problems, that particular performance problem will also impact or load this overall data center score. Now, in contrast, we also have the network score, which is how well users are connected to their desktop. So this means things like latency and packet loss in terms of how well their client is connected to the desktop running in your data center. And so as every user logs in, they'll have a network KPI score, and this is the overall score for every user throughout your Horizon environment. So this works across pods, across pools, across RDS sessions, as well as VDI sessions. All of that is really encompassed in these scores. And so what these numbers really reflect is, from an overall service perspective, this is how well your data center is providing performance for your users. So really the best way to think about this number is the higher the score, the better your data center is performing and the better the experience the users are having from an overall VDI and RDS host session perspective. Now, these numbers can be trended over time. Your default view that we give you is 6 hours, but if you're curious, like how did your service perform in the last 30 days? Well, here's your score, right? You can see that there are definitely some moments where the score is really high and you have some dips and peaks throughout the last time range. Now, you can also leverage some of the more advanced controls in the dashboard. So if you need to see what's an overall trend for the sessions over time, you can see that trend score just to kind of see how does your environment kind of stack up against a trend, and is it getting better or worse? So this is very powerful information. So the best way to think about this is, what questions are we really answering with these types of metrics? So, if your users are complaining about performance problems and someone comes to you as the service owner and they ask you, well, why are users having bad performance? Well, you have two numbers to back it up, right? Either the data center has a really high score and the problem's not coming from there, but maybe they have a poor overall network score. These numbers help identify that problem so that it's not the data center, it's purely how they're connected, or maybe it's both, right? In some cases, you could have issues where users are having poor VM performance or desktop issues or RDS host issues, and these numbers will basically reflect that problem within the data center. So again, look at these as high-level service metrics so that you know how well you're doing from a data center, as well as how well the users are connected. And just like the data center KPI, the network KPI can also be trended. So again, if you want to see, over the last 30 days, how users are connected, and in this environment, pretty much every user is connected remotely. So that particular score is going to have the most variability. So The good thing is, VROPS has the ability to learn what's normal, right? So what's the normal network KPI for our environment over time, you'll hear the term like dynamic threshold. So VROPs can determine, what's a normal range for our service and start to figure out, regardless of what the score is this a good score for us? Is this getting better? Is it getting worse? And you can actually alert based off dynamic threshold. So it doesn't necessarily have to be a hard number. So, if you wanted to create an alert that says, hey, when my network score gets to 50%, send an alert, well, you can do that. But if 50% is your normal score, because maybe you have, a lot of offshore people connecting remotely very far away, and they just always have really poor latency and packet loss to your environment, that could be normal, right? So again, VROPs can learn what's normal. VROPs can tell you, is this good or bad? But more importantly, you can trend it and determine, are we shifting in a better or worse direction? Now, additionally, from there, we have other high-level information such as, how many people are connected, how many users have adopted your service overall. So this is a total user count. But we also see things such as how many critical alerts that we currently have in the environment at the moment. Do we have any desktops in an error state? A load number is what you should expect. If you start to see really high error rates, that could be an indication of a larger problem happening within your environment. And again, all of these metrics can be alerted on. In addition to desktops, we also monitor, are there any RDS hosts in an error state? And you also notice that there are two scores for both, how many VDI pools have what we consider a red KPI. So a red KPI is basically any VDI pool within your environment that has a data center KPI score less than 25%, we consider that red. And I can tell you, if you have enough factors that are, from a performance perspective, impacting your users, driving your score that low, if this number is ever not zero, there are definitely serious performance issues within that particular pool, and it needs immediate attention. Same is true for farms. So from a farm perspective, if you have farms that are in a red data center KPI state, that score or that particular farm has a very low performance score, and is basically giving you a sense for how many of those farms or how many farms within your environment or how many pools within your environment have serious performance issues. So again, green's what you want, zero's the ideal number. If it's ever not zero, there's definitely, you need to do some additional investigation, and this dashboard will help you do that. Now moving on, so again, as I mentioned, this dashboard's organized how people or how users come into the service. So the very first layer in most customer environments are the Unified Access Gateway or UAGs, but not every customer uses that. So some customers may use purely internal connections. Maybe they don't require UAGs, so you can kind of ignore these particular widgets if they're not meaningful for you. But for a lot of customers, they are being deployed. So what are we looking for in terms of UAGs? So the first thing we care about is how well are they performing? And just to kind of show you that these widgets are all interactive, so I want to look at all of my UAGs. If I had a UAG that was having a performance problem, its overall performance score would be lower. So what does that mean? So as I click on these little donut charts, they're actually interactive. It should give you a list of which particular UAG has which performance score. So if I'm seeing UAGs with really low score, it won't be green or teal here. It'll basically be orange, yellow, red, something indicating that the overall score has been lowered. So in this case, this particular UAG has a performance score of almost 98%, call it 97%, something in that range, which means it's really high. So we know it's not having a problem, but let's pretend it is. So let's say that we come in here and we notice that its performance score is a 75. We're indicating that visually to you as a color. Let's just say it's red. And that way there could be a performance problem. So the next thing that we really want to know is what's driving that performance problem. So just like at the high level on the main dashboard where I showed you, you have a data center KPI and a network KPI. Well, in terms of a UAG, the data center KPI is the UAG's performance. So how well is the UAG's virtual appliance running on vSphere? How well is it performing, and is it having any performance issues? Because if there is a performance issue, we know that that can impact the overall performance of the users coming through it. So we want to make sure that this score is high. So in this case, we can see that the score is high. It's, it's 98%, so no problems here. So let's pretend that only the network score is low, right? So network score, let's say, is a 50, but our data center score is a 98. We basically just did very deep analysis for you. We basically told you, yes, there is a performance issue, but it's not the VM or UAG's performance. So it basically means that the users and how well they're connected to your environment is really what's lowering their overall KPI score. Now, if we were to see the data center score low, as well as the network score, we know that the VM performance is absolutely impacting the users and their protocol performance that's coming through them. So that's basically how those metrics are meant to work. And then we back it up with additional metrics. So what you'll see here is we have a metric around what we call an HTTP health check. And basically we want this to be a status code 200. It basically means the Horizon service is healthy, and that's the expected response. Additionally, from there, we notice how many users are connected. So we have 6 connected sessions. We look at overall utilization. So this percentage here is in terms of, the maximum recommended for UAGs is 2,000 sessions. So this is basically a percentage based off of connected to it. And then from there, we can see what's the overall average session latency and average packet loss. So again, ideally, we want these numbers to be as low as possible. We know in certain circumstances, that's going to be a little bit out of your control, but you can see the numbers here. But you can also see the worst latency and the worst packet loss. So again, we try to give you a sense for what's the overall average, but what is the worst connected user to the this particular UAG and how well are they performing. Now we've already determined that the UAG isn't adding overhead to that particular session. But again, to basically confirm that, we can see the additional metrics. So here we see overall CPU utilization. This is CPU ready time or performance. If ready time is high, it is basically impacting the performance of the protocol of the users coming through that session. Same could be true with things like disk latency or memory contention. We want these numbers to be as low as possible. Other valuable information is like how much memory are we consuming, what's our overall utilization, do we have any memory contention. As long as all these numbers are, we want contention to be 0. And this one I think is packet loss. Are we dropping any packets from the virtual NIC layer of the UAG? And again, we want that to be 0 as well. Now we'll just kind of further go down the rabbit hole here. So let's pretend that we were seeing some performance problems from an overall data center KPI, or maybe we just wanted to see more information around the users and the sessions connected to the UAG. We can simply click on the UAG's name. Now I didn't have to use that dashboard. If I know the object type that I'm looking for, again, so I've worked with a lot of customers, and sometimes naming conventions are difficult. So maybe you just want to look for your UAGs. You could search for an object type. So if you know it's a unified access gateway, you can just type out unified access gateway, and you'll see object type unified access gateway. And when you click on that, you'll see a list of UAGs. And then from here, we can click on the UAG, and it would have taken me directly to this particular summary page. So this is the summary page for a UAG. Again, if you know the UAG's name, or you're just looking for the UAG object type, this is one way that you can directly come to it. Now we've already navigated to it from our dashboard, so we can see more information around the UAG. So here we see that there are 6 connected sessions. We can see those trended out over time. So what's the maximum number of sessions we've had in the last 6 hours? But what's the overall performance? So again, overall performance is a combination, or really an average, of data center and network performance. So again, ideally all these numbers are as high as possible. But if the network performance is low, again, we just want to make sure that the data center performance is high as possible, so that we know that we're not contributing to that network performance score. So that's really our goal there. And then again, you see the average breakdown of session latency, worst latency, packet loss. Here's our overall health check again, just letting us know that the Horizon service is healthy and giving us a good response. Here you can actually see the response time of that request. And then you get a lot more detailed information about the UAG. So I'll kind of break down some of these categories. So from a UAG perspective, we can see the VM configuration. So what OS is it, its current IP, the host name of the UAG, what version of tools is running on the UAG, its current status, what cluster is it in terms of vSphere, and what vCenter is the primary host hosting this particular UAG. In terms of configuration, there's a UAG type, so that's basically a setting that you apply that lets you know that, hey, this UAG is servicing external versus internal connections. In this demo environment, we only have external connections, so you will not see any marked internal. We can see the current version of the UAG. We can see the health status from an API perspective. We can see how many current connected sessions from both BLAST and PC over IP. And again, response time. And what you'll notice is actually there's a new metric here called route latency and another one called route packet loss, and I'll go over that in just a minute. So let's look at some of the other performance categories. So here, this is again this high-level summary of critical KPIs that we want you to pay attention to, but then the individual boxes kind of give you subcategories of sub-levels of performance that you also want to look through and again get additional information around. So again, here's our overall UAG performance score. We can see that kind of matches what we have at the top. But here we have our UAG performance to route. So what these numbers represent is we introduced a new feature in the Magic Pack 2.5 that allows you to configure, in addition to the HTTP health checks, we allow you to configure what is called a ping check on the Telegraph agent. And what that allows us to do is monitor the overall internal network performance for the UAG and your external gateway. So if you basically want to configure the IP for it to ping as your external gateway or some, the furthest IP that you can reach on your network, that basically gives you the overall performance of how well the UAG is connected to the network and how much latency and packet loss that the internal network is adding to your Horizon sessions. So again, the best way to think about this is if you see users with poor network performance or poor connectivity, this particular route latency is the overhead that your network is adding to their connection. So ideally this number is low, and in this environment it's a little bit higher than it needs to be. We're showing almost 8 milliseconds. But again, this gives you visibility and insight to quickly rule out, well, is our network adding route latency and route packet loss to our sessions? And again, you can trend these over time. You can kind of see over the past, hey, there's a couple spikes up to 8.4 milliseconds, but for the most part, we're kind of running around 7.8. And the same for packet loss. So again, we can look historically to see, well, did we ever have moments of long periods of packet loss for our users? And while there were a few brief moments where we did detect packet loss, actually quite a bit, just 10% packet loss. But again, we have visibility into that. We could see that it occurred, and now you have a record that you can go back in time. So if you're trying to correlate network performance issues back to specific points in time for users connected to a particular UAG, you now have that data. Now, in terms of the VM performance breakdown, here we see CPU KPI. So again, as I mentioned, we look at things like utilization, are we pegging the CPU here? Ready time, which is again a measurement of CPU performance. And if any of these metrics are at a threshold that we consider bad or could be negatively impacting your Horizon sessions, we color code them for you automatically. So you don't necessarily have to know what's good and bad. But again, for ready time, typically we want to keep that under 3%. Once you're in the 5 to 7% range, we kind of consider that really high. And once you're above 7%, it's really critical in terms of CPU performance and the overhead that it's adding. Other metrics like co-stop gives you a sense for, is some of our ready time or contention that we're having due to we just have too many virtual CPUs. So again, that's another critical metric. IO waits, really looking for, is our ready time high because we're waiting for IO to feed the CPUs, right? Which could be another problem. So again, better insight into what's going on there. And then run queue is really an in-guess metric. So run queue looks at how much the CPU queues are being stacked up within the guest OS. And again, the idea is to keep this number as low as possible. From a memory KPI perspective, here again we see utilization, what's configured, do we have any contention? Again, ideally, we're not maxed out on memory, and we have zero contention, because again, contention is going to be our biggest performance factor, right? And if we're fighting for resources on the hypervisor, contention would slow down memory and basically, cause performance issues. And then you have page in and page out rates. So again, you can see paging within the environment to see if there's any really long periods of massive paging that could be an indication of an internal guest OS application performance problem. So again, critical to look at. It's not always indication of a problem, because again, typically, we expect memory pages to spike when things start up or things just aren't in memory. What we don't expect is them to stay high for very long periods of time unless you just have an application that's designed to do that. But as you can see in terms of the UAG, that's not really how it functions. So if I go back and look at 30 days of data, yeah, we have random spikes off and on, and we expect that, but you don't see any here where we have like 5,000 pages per second and it's just pegged for long periods of time. So again, very important critical metric to see, but just, be cognizant that you have to consider additional context and other things that are going on to whether or not it's a real problem or not. And then in terms of storage KPI, critical metrics here, we're looking for latency, right? Do we have any disk latency, overall latency, read or write? And do we have, like CPU queuing, do we have large amounts of disk queuing? Again, ideal is to keep this low. And then here we can see our overall connection breakdown. So this is looking at how many people are connected, sessions utilized, average latency, worst, packet loss, and so on and so forth. And then we can see the actual sessions connected to this UAG. So we do have the ability to do that within the Dimension Pack for Horizon, which is a unique feature for it. So it can kind of basically map out which users are associated to the UAGs. You can see which ones are connected, which one has the worst performance, and what's driving it. Is it, the data center? Is it the protocol? Is it CPU or VM performance? All of that's kind of captured here. You can see login times for these sessions, current agent versions, which client they're connected from. Sorry, current version they're connected from. We can also see the associated pod or connection servers related to this UAG. So again, if there's a problem with your UAG and you're wondering, okay, well, which connection server is related to it, you can see them here in this list. You can expand it out. And again, you can look at your connection servers. You can sort them by their overall performance. Are they failing health checks? Which one has the most sessions? Are any of these pegged on CPU, having performance problems? Here we can see we do have some disk latency on these particular servers. And we can also see that route latency metric that I discussed. So in addition to just UAGs, we also support monitoring internal route connectivity from your connection servers as well. So if you have dedicated connection servers that only serve internal people and their particular either sites or networks that you want to monitor, you can configure the ping check for that route, and then you can see the overall latency and packet loss to that particular route. And again, that's critical information to monitor that network performance. And then from here, just additional information. Do we have any unvalid certificates? Do we have any services that aren't in an up state, or maybe they're just not configured? Are we not collecting data from certain connection servers? This overall build number and version. So again, a lot of information directly just from the UAG summary page. And again, this is only one hop from our operations dashboard, which I'm going back to now. But you can see there's a lot of rich information. So if you were having performance problem with the UAG, you can quickly go into that UAG, do a deep dive analysis as to what problems are going on, and then you can take corrective action depending on which problem metrics you're having. Okay, so now we're back on the Horizon World Operations Overview dashboard. We just went into a deep dive around UAG performance, how to look for it, how to do some root cause analysis on it, see what sessions could be impacted by any performance issues at the UAG layer. The next thing that we really care about is the UAG functioning. So we talked about the HTTP health checks, and again, what we're looking for here is that all UAGs are coming back with the 200 status code, which is green. If you see any that are red, which would be a 500 status code, that indicates the service is down. So for that type of alert, not only do we want to visually be able to confirm, do we have any UAGs down, but it's also good to alert on these types of metrics. So don't just wait for someone staring at a dashboard to see this. Have an app on alert when this HTTP health check is a 500 status, and then that way you know to start taking corrective action when that occurs. Now you can kind of automate that as well. So if the health check is down, you can kind of have VROPS, reboot the UAG or whatever steps you want to have happen. But all of that can be automated. But the important thing here is to make sure you're actually alerting on it so that you know that it's occurring. So another critical metric in terms of UAG is how well sessions are being load balanced across them. So this is really being displayed to us from this UAG current session disparity. So what this means is we look for the connected sessions across all UAGs, and we look at how well they're being load balanced. So now this particular environment has a very low number, but what you'll see in various environments, depending on how well your load balancing is configured, if you start seeing high amounts of disparity, it usually indicates it's usually an indicator that something's going wrong from a load balancing perspective. Either it's not configured correctly, or maybe it's that the UAG is no longer satisfying and accepting new connections. So again, this can be an early indicator that either you have a configuration problem, or there's a further problem from a service perspective that could impact your users. So it could be something that you might want to do an outbound alert on, just so you know when it's occurring. But this is really dependent upon your horizon architecture design. So, sometimes, I've seen customers mix and match internal and external UAGs in the same pod, and it can kind of give you weird numbers when you do that. So I typically recommend to separate those pods out, keep your internal users separate from your external users, but that's not a requirement, right? So it's really just a best practice from an overall visibility perspective, but again, that's not a requirement. But here you can see what's driving it, right? So we're saying we got roughly 71% disparity or difference in the number of connections going to each UAG. This one has 1, this one has 5, and again, that's just giving us a visual indication that that's happening. All right, so beyond disparity, so this particular widget goes into internal versus external connections. If we had internal UAGs, it would have a separate column indicating which ones they are, but here we don't have that. But basically what this is just showing, so if you were trying to compare how our internal versus external UAGs are performing, or which one has the most sessions, this one basically calls that out. So again, you can see these are all external UAGs. You can see their overall performance and their health checks. And again, if you're just trying to compare outside versus inside, this is allows you to do it. All right, so the next widget is the UAG detail breakdown. So in some cases, you don't necessarily want to focus on one metric. So the distributions are good at looking at one type of metric and giving you a sense for who's the offending object, or which UAG is bad, which one's good. But some cases you might not know which metric you want to sort on. So we'll give you a detailed list. This would list out all your UAGs. We only have 2 here. But again, we can sort by any metric that's important to us. Sometimes we might be looking at connectivity. Do we have any UAGs with no sessions, right? That might be a question that we have. Do we have any UAGs failing health checks? Do we have any UAGs with performance problems, or where their average latency is off the chart, or maybe maxed out on CPU? Again, list views can be very useful for listing out all the metrics that you want to see really quickly, so you can sort by any of these metrics that's most important to you. And again, you get a lot of detailed information on the view. So again, version, health status, how many's connected, all that's laid out here. And if you want to directly click into one of these UAGs and go back to the summary page, you can do that as well. All right, so the next widget I'll highlight here is the UAG net performance to routers. So this is, again, going back to that feature we mentioned on the Telegraph regarding the ping check function. This basically helps you to quickly look at all your UAGs and see their performance over time along the route that you're monitoring. So in this particular environment, you'll notice that, hey, we got these little blue spikes. Well, what is that blue spike? Well, at this moment in time, we had 10% packet loss. And you can kind of see that these blue spikes, they're not unique, right? They do happen randomly throughout the day. Now, the good thing is they're not hard down, right? They're not like 10% for 3 hours or something like that, but there is some type of little network performance glitch that does seem to be occurring, and now you have a visual record of when that happens. And the same is true for latency. So for the most part, you can kind of see latency hovers right around 7.8 milliseconds. But we had a moment of congestion where, hey, it did go up a little bit, maybe not large enough for us to be concerned about, but it deviated from our normal. So again, you can alert when these types of things happen, so you can use URUPs to determine, okay, what's a normal baseline latency for this route, and when it gets above that certain level, you may want to be alerted when that occurs, so at least you can visually know that that's happening, because again, this is overhead from your network to the people connected through their client to their desktop. Now, beyond monitoring route performance, we can also have trending information. So the disparity widget highlights how much imbalance do you have. So it's a good, quick, early indicator, do I have imbalance? But maybe you want to trend that imbalance over time. So this particular widget allows us to do this. Now, our numbers are so small, you'll kind of see here that, as I mouse over, you can see 4, 5, and 0, where there are periods where one UAG gets sessions, the other one doesn't. Now, one thing I can do, so just looking at some additional chart controls, is I can turn off the static thresholds. And when I do that, now we can see it trended much more granularly, and it's kind of scaled more just for how large the data set is. So again, now you can more easily see that there are periods of times where UAG number 1 gets most of the sessions, and UAG 2 definitely gets a smaller amount. But then you see a period of time around April 15th where that kind of flips a little bit. Here you can see now UAG 2 is getting more sessions and the other one's getting none. But again, just a good visual representation of, are we maxing out our sessions on any particular UAGs? That's what those static thresholds will show us. So those static thresholds are basically the hard limitations that we're going up to. So kind of a warning at, what is that? Looks like about 1900, then another warning at 1950, and then when you get to 2000, that's the absolute limit in terms of supported sessions. All right, so outside of UAGs, we do very similar things for connection servers. So on the connection server side, here we're looking for connection server performance problems. Do we have any connection servers that may be experiencing issues with virtual machine resources? Again, if you don't see a green color or a blue color, it's typically an indication that the score is not ideal. So once you start getting to yellow, orange, and red, it'll indicate the severity of the performance issues that you're having. So here we can see a list of our connection servers, their current data center performance scores, and then we can just see some supporting metrics as to what might be driving that performance factor. As I showed you earlier, it's just disk latency that we can kind of see in this environment. But if there are any other offending metrics, they'll be listed here as well. And just like before, if you want to click into another UAG, you can simply click from here. Connection server, and it'll take you directly to the connection server summary page. So each object, whether it's a user, whether it's a pool, a connection server, or UAG, it's going to have its own dedicated page, and each page is relevant to the object that you're looking at. And then we prioritize your summary metrics and your performance metrics based off what's required to get better visibility and root cause analysis for that specific object. So here we're on a connection server. We're looking at the number of connections that it has. We're looking at disparity. Again, disparity in a connection server is comparing it to how well am I getting connections compared to my peer. And we'll kind of compare that, go back and compare that in a minute. We can look at overall utilization in terms of, hey, we're allowed 2,000. We're at, it says 0%, so a really low number. But we can also see critical issues like, hey, is there any LDAP replication issues? Is the server status considered okay from an API perspective? But what about the service itself? So we're actually querying the service with those health checks, and we're expecting our 200 status code, so we can see that information. And then we get into some of the configuration information. So here's the VM information, its IP address, its tool versions, very similar to UAG. And then some of the horizon configuration properties of the connection server. So, is it currently enabled? Here we can see the replication status, the current build and version number, what's its DNS name, is it using the default cert, is it a valid cert? We can click this to page to the next page. Is the cert invalid for any reason? If it had an invalid reason, it wouldn't be a question mark, it'd actually give you a reason. And then, are your services up that you have enabled here? And then fairly similar for UAG performance, and I won't go through to the exact same level. We can see the overall connection server performance. You can see how it's trended over time. Were there any points in the past where, performance had a momentary dive, or was it low for really extended periods? Could be critical information. And just like coming from the operations dashboard, we can still see that route performance directly on this specific connection server. So we can look at its latency over time, and did it have any large network spikes in terms of latency? Did it have any packet loss along that route, and how much was it, and when? And again, very similar CPU and memory KPI metrics. Again, I won't go through every single one again, but they're going to have the exact same level of importance. So if there are any metrics that are offending, they'll go from green to yellow, orange, red, depending on the severity or how poor that performance is for that particular metric. Okay, so now we're back to the operations dashboard, and we just discussed Horizon Connection Server performance. So let's look at some additional widgets here. So just like UAGs, We care about the overall connection server service response, which is performed by the HTTP health check. Again, here we're looking for all of these to be green. If there were any in a 500 status, it will require you to take action or remediation, which could include restarting the Horizon services or the entire connection server itself. So again, this type of metric, just like on the UAGs, I do recommend doing an outbound alert on. So when it does occur, you'll have a notification, you can take immediate response. You can also consider leveraging some of VROPS's automation capabilities, so that if you wanted to automatically reboot a server, you can do that. But you know, with any automation, just be careful that you design it appropriately. All right, and just like our UAGs, we also care about connection server disparity. So in this environment, we can see that we have very high disparity from our servers, and we're saying they're basically 100% different. And the reason we're saying that is, well, you can see connection server 1's getting all 8 connections, connection server 2's getting 0. So again, not very high numbers here, but again, there is an indication that we aren't getting proper load balancing within the configuration within our environment. Now, in other cases, if your service is down or there's something else going on, like maybe it's failing health responses, knowing that the health check has failed and you have higher disparity is just more information. So, you know, in VROPS, you can make your alerts as custom as you want to be, right? So you can say, okay, well, in my disparity alert for my connection servers, add in additional metrics such as what is the current HTTP health check status? Is it a 200? And if it's not, now you have additional information that you can use in the alert to take action on. Same is true for LDAP replication. So again, LDAP replication is critical for your Horizon pods. Ideally, you see this big blue bar, which means I have 2 connection servers with 0 replication errors. So I can click on these, I can see that that's true. But if you were having replication failures, you would have a bar over here that would be yellow. So the number of replication errors you have in the pod, the worse the color. But again, any replication errors could be a problem and it could impact the availability of the service, so you do want to take immediate action. All right, so just like our UAGs, we had a connection server detail breakdown. We have the same type of list here. So here, what we're again listing all the critical KPIs that are a priority for most customers. Here again, you would see all of your connection servers throughout your entire environment. So if you had, 10 pods and 20 connection servers, they would all be listed here. And then you could list them by any metric that's important. So list them by performance, list them by, do I have anything failing health checks, any replication errors? Are we having any servers where the CPU is maxed out? All that's being called out here. If there's any CPU performance problems, here we can see the exact same disk latency issue that we mentioned earlier. And we can also look at all of our connection servers and their route latency and packet loss. Do we have any services that are not in a configured upstate? Any certificates that are invalid? Any builds or versions that don't match? So you can quickly access that from here. And then just like the UAGs, we have our connection server net performance to router. So if we just want to monitor how well the connection servers have been connected to their routes over time, this particular chart will call that out for you. And here we have our connection server trend. So again, just like our UAGs, maybe we had good balance in our UAGs. We don't currently in this environment, but let's pretend that they were evenly balanced and our disparity was really low, but then we noticed that our disparity was really high. Here we can visually see that connection server 2 in this environment is getting really all the sessions, and connection server 1 stays really low. But then here it kind of swaps, right? Here you see that it goes from now 2 is getting nothing and 1's getting everything. So again, just that historical record allows you to visually see, do we have any connection servers at their maximum number of connections, and how well are they balanced? So a great way to trend that across your environment. Okay, so let's now talk about VDI pools and some of the analysis we provide at this level. So from a VDI pool perspective, there are numerous things that we care about, but let's talk about pool provisioning. So here the first widget is outlining, which pools are in a provisioning state of false, meaning they're no longer provisioning. So this could be depending on, is it disabled? Did you intentionally disable it? Or maybe it's failing because it's not able to provision. This could be a key indicator that something's wrong with provisioning in a particular pool. Now, typically the approach I would take is, so again, we have 3 pools that's in a provisioning status of false. But another critical information here, if you notice, there's also a last provisioning error. So if I was doing an alert on this, I wouldn't just look at, is it false? Because maybe I disabled it on purpose. What I would look for is it false, and is the last provisioning error not NIL, which means there is a provisioning error, and there is information in regards to why the provisioning failed. So with those 2 pieces of information, I have much more actionable information where I can create an alert and say, hey, my primary VDI pool, and maybe you could even specify which pools you want in there. So you can even tell it which names you want to look for. Or hey, only show me pools where they have at least 1,000 desktops or 100 desktops, whatever the number may be, and use all of those additional information to make your alert much more refined and much more meaningful, so that if provisioning is false, there is a provisioning error, and this pool has a lot of desktops. Maybe you even have a lot of desktops in an error state. You can use all of these metrics combined together in the same alert to make that alert very operationally actionable. And when it does occur, again, from here you can kind of click on the pool name. You'll see very similar information. You'll see that provisioning is disabled, how many is connected, how many are available, there's 0 available. So this particular pool really probably is in use because it looks like it's just a dev or testing pool. But again, if this was a production environment, that might be meaningful for me to watch, to monitor for, send out an alert that it's occurred, because you want to take some operational actions to restore that provisioning back to normal. Okay, so beyond provisioning, another area that's of concern would be how many desktops are remaining or available in the desktop pool. So available is desktops that are in an available state, meaning a user can log into it, no one's using it or consuming it, and there is additional capacity of availability in the pool for new users to log into. So when that happens or gets really low or 0, you'll see that, hey, here's our pools with 0 desktops available, and based off their configuration, you may choose to add more resources directly to it. So I'm trying to find a different pool, so I'm going to introduce a new metric. Unfortunately, all these pools have really good factors. Okay, well, so in addition to just looking at availability, so traditionally trying to alert on availability by itself as a percentage, as a number, gets really tricky because you can't just say, hey, I want to monitor for when all of my pools get to 10%, then send me an alert, because you might have a pool that has 2,000 desktops versus a pool that has 10 desktops, and the number of 10% isn't useful because at 10% of 2,000, you got 200 desktops still there. Well, you don't need an alert for that. But when it's 10 and you have 10% left and you're down to, let's say, 1, well, then that is meaningful, right? You might need to add more to it. So what we've done is introduce this idea of an availability factor, where very simplistically, we want that availability factor to be 1 or higher. Now it could be lower than 1, but the lower it is from 1, so let's say it's 0.5 or 0.3. When it gets to 0.3, the lower that fractional score, the more risk you have in terms of availability. So if I have a pool of 2,000 users and my availability, my availability factor is a 0.3, that is a good indication that based off how many are available and how many are configured in my pool, that I'm at risk of potentially needing to add more desktops before I run out. So that's really how that factor is meant to be used, and you'll see it in our latest pool availability alert. So we don't just alert on availability, we look at the availability factor, and based off that fractional number that you get below 1, we will say it's a warning, a critical type of alert, and you can decide to take action. So that's really what that's meant to show. And let me go back to, let's see, any of these pools. So I don't know if these pools are actually configured properly, but I'll try it anyway. So from here, yeah, I've just clicked on this pool a minute ago. You'll notice that there is an option now available. So in 2.5, we added some automations, our first automations for integrated with Horizon. And one of them is around VDI pool capacity. So if you get an alert that says, hey, you're out of capacity, now you can actually come in and say, reset what's the number of maximum desktops, how many are currently configured, how many spares do you want, so you can see what is configured versus what you want to set it to, and then you click begin action and it can increase the size of that pool for you automatically. So again, that is an automation that was added in 2.5. Okay, so beyond just overall availability of how many desktops do I have in a pool, another critical error is around desktops and them being in an error state. So error state's not good, right? It usually means you have a desktop that's not functioning. And if you have pools where that error rate is high, it's an indication of a larger problem on the pool. So here, we're good, right? We have all of our pools where there's no errors in desktops. That's fantastic. But let's pretend that one of these pools had 50 desktop errors. So what this particular chart tells me is if this number is not 0, let's say it's 1. It's basically telling me that I have one pool where there's at least 30 to 50 desktops in an error state. And if there were pools here, I could click on it, interact with it, and see which one it was. So unfortunately, there's none in an error state that I can demo to you. But let's see here. This is our primary discovery pool. So if there were desktops in an error state, again, you're going to get an alert that it occurred. And in addition to the update VDI pool action, you would see another action that says recover desktops from their error state. So again, yet another automation that you can send an outbound alert on. And when it does occur, VROPS has the ability to go to try to recover those desktops. Now, for it to work, whatever's causing the problem cannot be something like, hey, DHCP down or Active Directory's down, or something's not functioning within the environment preventing their recovery. So if it's something that was momentary in time, and maybe just desktops got when they were created, maybe they didn't finish provisioning or something along those lines, we should be able to recover those. But if there are desktops that cannot be recovered because, again, there's something within your infrastructure causing a problem beyond what Horizon has control over, then it's just not going to function, right? It'll try to recover them, but whatever is failing will still be in a failed state. So just keep an eye on that and keep that in mind when you're trying to use that new automation. Okay, and so the next widget after error status, we have our VDI pool login time. So this is really looking for which pools have the worst login time. So if you're trying to not necessarily figure out which user has the worst login time, sometimes you might want to know, are there different pools that have higher login times than others? So that's what this particular widget is supposed to answer. So in this particular case, this discovery VDI pool, the worst login time for it was around 95 seconds. However, this pool, we have users logging in at 9.6. This pool's around 38. And you can kind of see as the login time is higher, the color changes. So again, just an indication of, very quickly from a pool perspective, which pools have the worst login times versus worrying about which users, right? Because sometimes you might be trying to figure out, well, do certain pools have worse logger times than others? And this type of widget will call that out for you. Now, similar to our UAGs connection servers, we have a list of all of our VDI pools. So if you were to expand this out, again, you can see when you start having more items to display, you can sort by much more information. So here, maybe I just want to sort by who has the most connected sessions, or maybe who has the worst performance. So what's our worst performing VDI pool? And from a data center perspective, but also what's our worst performing pool from a network perspective? Or do we have any users with high CPU ready time or disk latency? How many desktops are in an error state? So this particular widget answers a lot of questions really fast, because if you look at these categories like high CPU ready time, this is basically counting how many people in that pool have that problem, right? So if I go to my discovery VDI pool and it says, I got 50 people with high CPU. Well, if if I know that that particular pool only has 50 desktops and all 50 of the users have high CPU, that's a good indication that this pool is not optimized in terms of how much compute's necessary to do their work. The same for ready time. So if I have a large percentage of desktop users having CPU performance problems, again, this is a good area of focus. I need to maybe pay attention to the pool, maybe look at the cluster that pool is running on, and seeing why is that particular pool having such a high or poor CPU performance rate for the users that are connected. So that's what these numbers mean. So when you see things like high disk latency, desktops in error state, these are all counts. So how many users have high disk latency? 0. That's absolutely what I want to see. If I see that it's 50 or 100, that could be a big problem. So the number, of course, is going to relate to the size of the pool. If I have a pool of 1 and only one has a problem, then everyone in the pool has, you know, poor connectivity. So all these numbers are kind of relative, but they are kind of calling out for you the most meaningful KPIs that we can give you. You know, I mentioned like availability factor. So again, you can see all of the pools listed out in terms of their availability, but you can see their availability score, so you know if it's good or bad. Here we can see like worst login times, worst profile load time. Is the pool still enabled? Is there any provisioning issues? What's the data store capacity, configured CPU and memory capacity? Again, just high level stats. And if you wanted to do some further analysis on a pool, so let's again go back to our Discovery VDI pool. You can simply click on the name. If you weren't on that dashboard and you knew which pool, like let's say you were getting complaints about a problem on a pool, again you could search for the name Discovery VDI pool. I could have clicked on that. It would have taken me directly to this page. So I didn't really need the dashboard to get here. And then from here, again, summary box is always critical metrics up top. How many people are connected, availability, desktop error rate, but how many users have what problem? So again, we're doing the analysis for you, so you're not going to all your sessions and looking at all your users and determining, does anyone have high CPU? We just tell you the answer, right? So you don't have to do a lot of detailed analysis. So I can go back 30 days and say, hey, did I ever have a large number of users in this pool that ran out of CPU? And based off this pool, most it ever had was 1. Here we can see 2 are connected to it. So this pool is configured for, looks like 15 total. Yeah, it's configured for 15 desktops, or configured maximum 15. So I know out of 15 desktops, only one of them at most at a time had high CPU. Now, how many users in the past 30 days had CPU performance problems? 0. This is good information because now you're not having to dig through every single metric, look at every single desktop and every single user. We simply give you the analysis of the pool and let you know, did something happen? Did you have users that had CPU performance issues? No, you did not. Did you have users with high disk latency in the last 30 days? Well, I see a couple spikes on that previous chart. So if I look, most I had was 1. Again, 1 out of 15, one had high CPU. Probably not going to spend a lot of time in research to figure out why, just because it was 1. If it was all 15 or a high percentage of them, then sure. Did anyone run out of memory? No, they did not. Now we get into connectivity. So again, if I'm going to go back and look at 30 days, how many users all at the same time had poor connectivity to the pool? And at most we ever had was 4. But if you look at it from maybe an average perspective, maybe it was like 1 or 2, right? So that basically tells me that in general, people have good connections to the pool. And beyond that, right, we can look at packet loss and say, okay, in the last 30 days, was any packet loss? No. So fantastic, right? So we just learned a lot of information about our pool all in one summary box. Now beyond that, again, we can see the properties of the pool. We added this new metric called image mismatch. So, when you're doing provisioning operations, sometimes you might have users locked into a session or they don't get logged out. And for whatever reason, you get these VMs that did not have a provisioning occur. And so they'll have a mismatch, meaning, yes, you did a provisioning operation, but you have some VMs that did not take the new image. So what this does is, again, it alerts you or gives you visibility that that's happened, right? So if this number wasn't 0, for one, it wouldn't be green. But let's say the number was 10. So that basically tells me there would be 10 desktops that don't have the latest current image that's been provisioned to the pool. So very powerful information there. We can see what's configured on the pool. Is it configured to suspend on error? What's the total CPU capacity for the pool, memory capacity, data store capacity, what's the agent version for the pool. So very detailed information. Image state, what image are we on, what's the snapshot path, and what's the overall source. Is it an instant clone or is it persistent desktops? Okay, so getting into some of the more detailed analysis of the pool, here we're looking at overall capacity of the pool. So where this information comes in handy is looking at more of how well are we optimized in terms of the resources we provisioned. Like, have we over-provisioned, have we under-provisioned, how are we doing? So the first number you have is usable capacity, so it's really looking at, based off the number of desktops that are configured, how many is remaining. So if this number gets really low, 0%, then we know we're out of capacity. But we also have the availability risk factor, so we know that, hey, as long as we're above 1, we are very, very low risk. So even though let's say I was at 5%, as long as my risk score is above 1, I probably don't need to worry about adding new desktops to the pool. Now, in terms of what's configured, as I mentioned, this particular pool, based off the number of CPUs and their current speed, this is the total CPU capacity. So this pool basically has almost 117 gigahertz of resources configured for it. Now let's compare that to how those resources are used over time. So again, if I want to look at 30 days of data, and I need to click the go button, I can see that at most I use 20 gigahertz of resources. So comparing that 20 gigahertz to 117, I've significantly over provisioned, right? This pool definitely does not need the resources that has been given it, and there could be consideration for optimizing further. Now we'll talk a little bit more about what are some of those other considerations, but already just kind of looking at this, we're not optimal here. And then in terms of memory, we can see we've given these desktops 120 gigs of RAM, but we're basically using a third of that. And so if you want to see how accurate is that third, and you go back 30 days and say, okay, well, at most it was up to 60 gigs, but clearly nowhere near 120. So at least half of that could potentially be reclaimed. And then here's basically just kind of looking at data store capacity over time. So, are we low or running out? All right, so just kind of staying on the capacity topic, so how do I know what do I really need to adjust and what are some of my options here? So in addition to just pure capacity and how it's being consumed, we also have analysis on the sessions of the users that are connected to it. So the way that this works is as a user has a desktop session, it doesn't matter if it's a persistent desktop pool or non-persistent, it doesn't matter if a user gets a new desktop every time, we keep track of the user's CPU and memory consumption. So we know for every user connected to the environment, are they oversized, are they undersized, and how much resources do they really need to do their job? So from here, based off the 2 sessions that we have, we're basically saying both users are oversized. And based off this number of users is suggesting we can remove up to 4 CPUs. Now, I know based off the configuration of the pool, because again, the VM's configuration is 4 virtual CPUs, and I'm saying, hey, for these 2 users, I can remove 4. It's saying both users need half of what they got. So I effectively can go from 4 CPUs down to 2 configured on the image of the pool, right? So basically making the image 2 virtual CPUs. And that's historical analysis, right? So it's looking at how over the last 30 days, how much did I consume and what do I really need? Same is true for memory. So on the memory side of things, I'm trying to remember, this is saying I can remove 8 gigs of RAM. I think these pools are configured for 8 gigs of RAM, but it's basically saying half. So it's saying, even though I gave these users 8 gigs of RAM, they need roughly half of what we've given them. So more room for further optimization. Now, we have to take some numbers and scale into context here. So what I would say is, when I'm looking at oversized versus undersized, so no one is undersized in this pool, that's good to confirm. If I did have users who were undersized, I might consider moving them to a new pool. I might consider upping the size of the image. The question is going to come down to scale, right? So at the top, we can kind of see that our problem isn't really undersizing, it's purely oversizing. But I really have to think about the context of how many users are in the pool. So if I have a pool of 1,000 desktops, and I'm saying that 900 of those users are oversized, that's a good indication that my image is not optimal to my pool, right? So I confirmed I'm not using the resources. I confirmed that there's a large percentage of the population that doesn't need the resources that we've given them. I need to make some adjustments. And so this is where you could go to the image for the pool, and based off the recommendation of how much compute you could potentially remove, you can think about removing a virtual CPU or two, depending on how far off you really are. So again, if my oversized users is 900 and it's saying I can remove 1,800 virtual CPUs, that's basically saying half, right? Remove 2 CPUs from the image, right? So that's your quick math. Take my oversized, divide it by how many CPUs I can remove. That's how many I should pull from my image. Now, what about the other 100 users? Well, so if I have 100 users that are either right-sized, we might be causing issues for them, and that might cause us to have some undersized sessions go up. But if I have 100 people that is just those 100 people that demand more resources, why not just make them a new pool? I can make them a new pool. I could look at their historical usage. So here I can come to the users. I can see how well their current sessions are performing. Are they having any performance problems? And I can see which users are oversized and undersized. And then if I want to look at their individual data, I can go to the user and say, okay, well, this user is oversized by 2 and 4, right? So basically the exact same math we did on the previous screen. So this just helps me to confirm it. So again, as I mentioned, this user level oversized data is based off historical patterns. If you wanted to double check and just confirm, okay, well, is VROPS crazy, or do they really not need 2 CPUs? And again, if we look at the data, yeah, you had these random spikes. Maybe it was at a login, but other than 1, 2, 3, 4 moments in time where it spiked to slightly above 50%, this user doesn't need the resources that's been given, right? It's definitely well below that 50% threshold, which is a good, clear indicator that they do not need the amount of resources we've given them to do their work. So again, this is a good way to confirm that. But all of these metrics are available, right? So wasn't trying to get too much into the user performance or user analysis side of things, but at least on the pool side of things, it is important to know which pools have which problems, how to optimize them, how to make them better. What you also notice is we've also introduced pool cost analysis. So here, based off how much compute the desktops in the pool are consuming, now you know what it's actually costing you to run that pool. So if you have like chargeback considerations or just internal showback considerations, how much does each pool cost? Those metrics are now available, and you even get in a total cost per desktop per day. So if you want to know, if you're trying to get down to utility-based billing, which I don't usually recommend, you can kind of do stuff like that. Where you can say, okay, well, hey, this user used it 10 different days out of the month. We're going to charge them 10 times $13, and there's their chargeback scenario. In addition to capacity analysis, so that's really what we did there, you can also get the performance breakdown. So again, at the pool level, based off users consuming their desktops, now you can see how well the pool performed. And the reason we've taken this approach is, sometimes it's important to know how well did a particular pool perform over time. Every pool gets a score, every farm gets a score, but now you could see that score historically. You can see times where it's fantastic, you can see times where it wasn't great, but again, we're doing that analysis for you so you can quickly see and determine, were there any data center performance issues? Were there any connectivity issues? What was the worst performing session in the entire pool? How many sessions are red? So red is, again, your data center score has to be at least 25, which is pretty low. So 100 is a perfect score, 25 is really bad. Just like our UAGs, again, you can see the average latency to route, packet loss, that's all trended here. Again, for CPU performance, really what we're doing is we're counting the things that are bad. So how many people had high CPU, how many had performance issues, what was the worst CPU ready in the pool, what is it right now, what has it been historically, so you can go back in time and says, oh, well, 0.38, that's nothing, I'm not worried about that. Now on the memory side of things, very similar. Do you have any sessions out of memory? Do you have any sessions with excessive paging? How bad is it? What about disk performance? What's the worst disk performance throughout the entire pool? So that's really how these metrics are meant. It's meant to be, look at your pool, get a quick snapshot analysis of all the individual things that could be going wrong, do further analysis to say, okay, well, do we have any areas of opportunity for optimization? Are there any performance problems that we need to worry about right now, and what category are they? Are they one category or all of them? And then if you want to see the list of sessions on the pool, they'll be available. You'll notice actually one of them finally went disconnected, and it's still there. So again, you have that historical record of which users connected to the pool and what was their performance issues. And also on the pool, so you can also see, so let's say you were seeing a lot of performance issues. Well, how's the cluster performing, right? So the cluster has a data center score as well, and we could see it's basically 99, which is fantastic. But it's always good to look at the individual, right? So at the cluster level, it's an average of everyone. At the individual session level, it's more specific to the user. How well is that user's desktop performing? But here we can see the cluster's contention. What's our current CPU overcommit? 1 is fantastic, which I almost never see. Once you start getting to 3 is about probably, I would say, recommended best practice from an overcommit. I've seen as high as 5, but really that depends on how much demand and workload we're putting on that cluster. So it's really hard to know what the exact number is going to be for your environment. The best thing is to look at, are we having CPU performance problems? And if so, at what overcommit ratio do those problems occur? And you can actually chart these side by side. So I can actually have a chart that shows, hey, show me my data center performance or CPU ready time performance, and then compare it to when our overcommit ratio hits, let's say it's 3.5. Maybe that's the magic number for your environment. Now once you get to that ratio, your performance is going to degrade, right? So just a good way to do some quick analysis around the cluster and kind of comparing it to the pool's performance. But here we can see the demand, what's the worst CPU performance, the worst disk latency, do we have any memory overcommit or memory contention? Again, just the high level priority metrics. Okay, so coming back to VDI pools. So another thing I'll note is, yes, we do provide you a list of performance issues. But here, if you just want to do a quick analysis of a pool, so you can select the row. If you click the name, it goes directly to the object or to the object summary page. But if you select the row, it'll interact with these additional widgets. So basically, this is just a trending chart of various KPIs that we showed you on the VDI pool summary page, so you can kind of trend them over time. So as network and data center KPIs go up and down, you can kind of quickly see which factors are driving that. And the same for the cluster. So the supporting cluster for the pool will be displayed here, and you can kind of see which factors are being kind of driving any performance issues. Now beyond performance, here you can see, what's our most expensive pool. We kind of added that in 2.5. Which pool has the most sessions, which one consumes the most resources, most memory. And now we're kind of getting into RDS farm performance and analysis. Okay, so the first widget I want to highlight is our RDS farm worst host data center performance. So what this widget is intended to do is to give you insight into not just how or which is your worst performing farm, but do you have farms where hosts within the farm are having performance issues? And why is this important? So if you look here, this is just similar to our VDI pool list. We have a farm list. Let's look at the average data center performance. So this looks at all of the performance across the entire farm and gives that farm a performance score, and you can see these scores are really high. But notice when we look at the worst host data center KPI that, yeah, the overall farm is great, but there is a host in there that isn't great. So what this widget does is really it calls that out. So it helps you to find needles in the haystack. Is there a host within a farm causing an issue? And it could be multiple hosts. It doesn't just have to be one, but at least you can see that, hey, within a farm, there is a host that has the worst lower performance. Now, in this case, the overall average for the farm is 96, the worst performance 88. So again, you can kind of compare and contrast between the two. You see some additional metrics here, analysis, but let's just go ahead and click into the farm and start doing that analysis. We have this load. Okay, so here again, unfortunately, we don't have any currently connected sessions. There's actually 2 disconnected. Kind of see that trended over time. But we also have computed sessions remaining. So this is an interesting number. What we actually do here is, if you look under capacity, you'll see that we actually calculate what's the average CPU required per session and average memory per session. And so what we do is, okay, based off, let's say that, you know, we had 100 people on the farm, and our average for every session was that every user required a half a gigahertz, or maybe it's 1 gigahertz, right? So based off that 100 times 1,000 gigahertz, and then comparing that to how much compute is configured, we then determine how many computed sessions that we have remaining. So not what's configured, right? So configured is, hey, maybe you set up your farm to only allow 50 sessions per host or 30 per host, whatever the number may be. We may do it where we're calculating, or sorry, we're actually doing it where we calculate based off your current average compute per session, how many more sessions can you get in there before you'll have to start adding new hosts. So that's really what these numbers are meant to do. So this is a very critical number. You know, you can't alert on this number, but again, it's intended to give you insight into, do I need to add more hosts to the farm? So that's why it's listed up top. Beyond that, we're looking for a host in an error state. We're looking for balance across our hosts. So not just how well sessions are balanced across them, like, hey, is the load balancing algorithm evenly placing them across each host, but how well is CPU being balanced, as well as memory. So we look for CPU disparity and memory disparity, and then we're trying to figure out, is there a huge amount of imbalance between the hosts? Here we're just counting for you, you know, how many hosts have high CPU, how many have disk latency problems, low memory problems. So you don't have to go to every host and do analysis. We're just telling you, is that true, right? Is there a problem here that you need to pay attention to? And if these are all 0, that means they're all happy. And then in terms of sessions, there are individual sessions, we can see how many sessions have latency and packet loss, just very similar to our VDI pools. From here, again, we can see the overall configuration of the pool. You know, just like the VDI pool, we have the host image mismatch. So again, if we re-provision our RDS farm and we switch to a new image, does everyone have the new image? So we can see that. Here we can see what's configured in terms of resources, who's configured access for protocol type, and current image state. So all of these can be alerted on or put in a view or report depending on what you're trying to do. Now again, in terms of performance, again, we look for overall average, worst host performance, lower performance. Here we're also using the exact same average pod to latency route metric. So just like for any of the connection servers that's supporting the farm, it's basically leveraging that exact same metric, so you can see the impact for the route that these particular sessions would take. And then in terms of CPU performance, again, it's looking at overall utilization, worst performance for your host, what's the usage disparity of memory between them, do we have any hosts with really low memory, really high paging, or any disk performance problems. And as we go to the bottom of the farm, we can see the full list of hosts just like we do on the other screens. And then that way, if we're just kind of trying to figure out, okay, which ones are the worst performing ones, we can see, oh, it's this one. Okay, we can see it had one session. We can see its disparity was really off, meaning it was probably doing more work or way less work than its peers. But then we see the performance scores. So here we can see things like CPU overlap, IO weight, context switching. Wow, context switching is pretty high. So is disk latency. So disk latency is pretty high in this environment. What else is going on here? And really high memory paging. So again, just kind of quickly calling out that, you know, this kind of shows you what are your offending metrics, and you know how those offending metrics impact your score. All right, so from here, beyond the host, we can see the farm sessions, so which users are logged in using the farm. We can see their current performance score if they have a connected session. We can see what their latency and packet loss. We can see that's currently in a disconnected state. Any RDS, CPU, memory, IO, just basic session details. So what was their login time to the host, connection time, client version, all that's detailed. And then if the farm has application pools, you'll see a list here. So if you see nothing listed here, it means that particular farm is really just for RDS desktop sessions and not app pools. But because it does have app pools, we can see here's the applications that are being consumed. So you can kind of list them by, which sessions are going on. Are they still enabled, app version, and pool name. And then here we can see the cluster performance supporting the farm. So if there are serious issues within the cluster itself, they should be called out here. So again, overall performance, you can see the scores and then a breakdown of very similar KPIs. Okay, and just like for the VDI pools, we can select the farm. And when you do that, again, it's going to give you a trend analysis for the critical KPIs for this farm. So you can see how they trend over time, and then you can see sort of the numbers that are backing up what issues they may be having. Same for the cluster performance. And then just like VDI pools, you have, what's the most expensive farm, the most connected, which one demands the most compute per CPU, the most demand by memory. And then when we get towards the bottom, it's getting into more compliance. So in compliance, here again, we're just looking for how are people connected, like what protocol are they using? Are they using BLAST, using PC over IP, are they using the web interface? And this is basically outlines which session is connected via which protocol type. Here we can see sort of uniformity of what client versions are out there. So here you'll see Windows versus Mac versus HTML. But here we're looking at client versions. So this is very helpful in just kind of determining, do we have any users with really old versions of the client connected to the environment? Typically, we're trying to avoid anything that's at least not the same version of Horizon that you have deployed. But I've used this in other customer environments where they had the latest 8.8 or 8.9 deployed, and they had clients as old as 5 something still connecting in. So definitely could be a problem with performance issues because with each release, the agents are updated, the clients are updated, the protocol's been enhanced, and of course, if you don't have the latest agent versions and you don't have the latest client versions, you're not taking advantage of those performance improvements. It's very similar to clients here. The agents, we're just looking for uniformity. Are we all running the exact same agent, or do we have some pools out there where the agents are mismatched? Here we're looking at connection servers by build, so do all the build numbers match? So not just the version, but do the builds numbers match? Because maybe you have a patch release or something, and your build number, your build version shows correct, but the build number is different. So again, this kind of calls that out, so you can kind of see where you don't have uniformity. And then for connection servers, here we're looking for, do we have connection servers that aren't passing or don't have valid certificates? So again, that could be have a service level impact. So we definitely want to make sure these are always true. I've definitely used this in certain environments where, they didn't know that they were false. So kind of help them quickly find that, hey, here are some invalid certs and here's the invalid reason. And they just simply expired like a couple days prior to the meeting that we had. Here we're looking for, so if you're using things like True SSO or SAML authentication, we're just looking for problems in the configuration. So are there any errors on the True SSO side, or are there any configuration in how SAML is being configured for the pod? And so as long as these are blue, that means all your configuration is good. If it's not, where you see that, hey, you got a number of servers where there are connector errors, we can call that out for you on the particular pod, and you can take action that way. So that's really it from the Horizon World Operations dashboard perspective. I hope that you got a lot of today's session. If you have any questions beyond, feel free to post them and let me know what other questions I might be able to answer. But this is meant to be a good high-level overview and deep dive into really how to leverage this dashboard, take advantage of it, and really understand what the dashboard is meant to do for you and how it's meant to give you great operational insight into your Horizon environment, how things are functioning, how things are performing. If there are performance problems, how do you go deeper into it and do that further analysis? So thank you for watching.